Okay, here's example 3 of finding the area of the equilateral triangle, but now we are given the side being 6 inches. Well, since it's an equilateral triangle, we know all 3 sides are the same, and of course, these 3 angles are going to be 60 degrees each because it is an equilateral triangle. And pretty straightforward. When you're given a side of the perimeter and you want to find the area of an equilateral triangle, we just use the form of is specifically design formula, which is 1 times square root of 3 over 4 times the side square. Well, plug and chop, I got the answer 9 square root of 3 inches square. Now, what if we use formula for the area of any type of triangle? 1/2 times base times height. What are we going to get? Well, the first thing we want to do is that since we already know the base, we have to find the height of this triangle. So it's a dashed line like this. And of course, this dashed line is bisecting the top vertex or the top angle, and it's perpendicularly intersecting with the base. So to figure out this height, we're probably going to select either the left half or the right half of this entire triangle. I'm going to go with the left half. So with the left half, we know this angle is 60 degrees, so we put it here. This is 90, and of course, the leftover has to be 30 by the triangle angle sum theorem. By the 30, 60, 90 triangle property, we know opposite to 30 degrees is going to be the short leg denoted by x. Opposite to 60 is the long leg denoted by the product of x and square root of 3, or the product of the short leg and square root of 3, and opposite to 90 is going to be the hypotenuse denoted by the formula 2 times x. But since the base is 6 inches and it got bisected into 2 equal halves, we know this half and this half as well is going to be 3 inches. So this half here, this half here, and we know x is going to be 3 inches. And since x is 3 inches, we know this here, this side here, which is the height of the entire triangle, is going to be 3 times square root of 3 inches. So this is the height of the entire triangle. So pretty straightforward. Using the formula for the area of any type of triangle, we got capital A equal 1/2 times the base times the height, which is 1/2 multiplied by not this base, because this right here is just half of the entire base of the entire triangle. So we have to multiply by 6 inches, not 3. And the height is 3 square root of 3 that we found. Well, let's see. Simplifying, we know 2 go into itself, so 2 divided by 2 is 1. 2 go into 6, so 6 divided by 2 is 3. 3 times square root of 3 is going to give us 9 square root of 3 inches square. And this is the same result as the one that we are on top. Now, what if we use the formula for the area of any regular polygon? Well, we know the formula is 1/2 multiplied by the apothem and multiplied by the perimeter. But we know the perimeter can be found by adding all 3 sides of the entire triangle together. So 6 plus 6 plus 6 is going to give us 18. This is equal to 1/2 multiplied by the apothem multiplied by the perimeter 18 inches, like that. So we have to find the apothem, and then we have to plug this value in. The way we find the apothem is, the same as usual. We put this triangle into a circle, or we inscribe this triangle in a circle, and then we create the radius of the circle, which is from the center point here, go all the way to where the vertices of the triangle meet the edge of the circle. So this right here is the radius. The apothem is the distance from the center of the circle to one of the sides of the triangle. So, it intersects the sides of the triangle perpendicularly, hence the right angle. So this is the apothem of this triangle, and this is the apothem of this triangle. Like that, and these are the right angles. So how do we figure out the apothem? Well, we want to go ahead and take either this half or this half of the bottom triangle. You guys can go ahead and select this triangle and then select one of its half, or this triangle and one of its half. But I like to go with the bottom one because it's easier for me to see. So selecting the bottom triangle, I'm going to select the right half, its right half, which is this one. So by doing that, I'm going to have something like this. And we know this angle here is going to be 30 because this angle here comes from here, but this angle 60 degrees is bisected by the radius. So this half is 30, which is what I put here. And this other half is also 30. But we know this is 90, and we know this is going to be 60. Because remember, all three angles of any type of triangle has to add to 180 degrees by the triangle angle sum theorem. Well, by the 30, 60, 90 triangle property again, opposite to 30 degrees is the short leg denoted by a variable. Well, I'm calling it x still because easier for me to use. Opposite to 60 degrees is the long leg denoted by the product of the short leg and square root of 3. And opposite to 90 degrees is the hypotenuse denoted by 2 times the short leg. As we mentioned earlier, this half right here consists of only half of the base of the entire triangle here. So that means this portion or this side, which is the long leg of this little triangle from this right half that we selected, is going to be half of the entire base, which is half of 6 inches, which is going to be 3 inches. So we can set this equals to 3. Solving for x by dividing both sides by square root of 3. We know that x is going to be equals to, well, let's see, 3 square root of 3 over 3, which is just going to be square root of 3 inches. And this is going to be the apothem right there. So the apothem is square root of 3 inches. And of course, remember that this short leg, which is the apothem here, is denoted by x, but x is square root of 3 inches. So that's why we know the apothem here is square root of 3 inches. We'll just take this value and plug it in. Plug it into the formula here. So that means we have 1/2 multiplied by square root of 3 multiplied by 18. Well, let's see, we got 18 times square root of 3 divided by 2. 18 divided by 2 is going to be 9, so we got 9 square root of 3 inches square. And this is the answer.